Hello, everybody. Am I coming through okay? I'm checking. Just um, type something if the audio is weird or anything like that. But all right. Let's get going, I think. All right, thank you. So, welcome again to my second, I guess, or third live stream or attempt at one. Um, so, if you saw my previous stream, we were in the middle of making this procedural thing, which is it's called a catenary. So basically, it's a rope or a chain, um, and what I want to do is make a procedural mesh that connects 2 points as a cable would. So basically, what we have so far is this. So it's a mathematical curve that does the arc as if it were a chain or a rope hanging between 2 points. And what I want to do is create a procedural mesh for this. And this basically gives us a fairly convincing but representation like of a rope, but not using like a chain of interconnected rigid bodies, which would be really difficult to manage, especially in multiplayer and things like that. So last time I wrote up the formula for this. So it's there's a parametric equation for this, which is here. So basically, this is the meat of it, and it's basically this is the maths that describe what's called a constant length catenary, which is it's a curve like that that you can see, and it's but the thing is that it maintains a constant string length between the 2 points. So if I um, play around with the length of the cable, um, it will maintain this total length in between the 2 points, regardless of where the points are. And then what I also did later on off camera, I added some detection for the surface below so that if the cable comes down near the surface, you can see that it starts, it clamps itself to the terrain. So it's not physically clamped to the terrain, like you can drag it like this, but for what I want, this is probably more than good enough. And so the terrain clamping is just done using raycasts, and just basically finding where the ground is each step of the way. In fact, if I uncomment this little line here, you can actually see um, after it's done doing its thing, of course. I did say we're going to be staring at progress bars here. So yeah, anytime, Unity. Anytime. There we go. So these are the raycasts that are getting done. So for each step along the way of uh, along the way between points A and B, we do a bunch of raycasts, and if they happen to intersect the ground before the line does, then we clamp the catenary to the ground. So that's basically that. So I'm fairly happy with this. So, but this, like what you can see here, is still all being done, drawn by debug draw lines, which is not something that you will actually see in a game. So this is only editor-only graphics. So today, the job is to hopefully finish this out by making the actual procedural mesh, which is to say, like taking in the all the vertices, doing the triangles, like all the faces, to actually make this look like something. And so yeah, that's what we'll hopefully get done today. So let's get to it, I guess. So if you were with me on the last stream, I got as far as about here, where I had the points coming off from this method called make catenary points. It basically sets up the coordinate frame for the spline, because this the maths are 2D, so the catenary curve is a 2D graph. So what this does is we build a rotation coordinate frame to basically remove one of the dimensions and reduce the problem to 2D. So we take all of the points in 3D, which are the between world space point and world space point A and B, and we then walk through them, and we convert the points in between to a 2D point, which is this vector 2 here. Let me know if you can actually read the text here. I usually keep the text fairly small. So I'm gonna see, is this okay? Like, is this a good size? Because I realize it's not really, it kind of defeats the purpose, right? To do a coding live stream if you can't actually read the code. So, so yeah. So I added this bit here later on after the stream, where I added a flag to optionally toggle this collide with scenery thing, and the get catenary y function, which returns us the y coordinate of each point, now takes in this an optional function that that allows whatever's calling it to give it like a function of how to find the floor height at each point. So this is what this is doing effectively. So it just grabs the point that's being used and finds the floor height at the location and sends it back basically. And so we ended about here, and I don't remember if I actually added this the cross-section bit in the stream or not, but so this is the part that actually draws out each one of the cross sections of the rope. So you can see here that these are 6-sided cross sections, and that's done by this part here. So it basically just oh yeah, right. I think that this part I actually didn't show. I think this was after the stream as well. I was just poking around at it, and it and wrote this method. So basically, once we have all of our points, instead of just drawing the points directly, which I think is how I left it at the end of the last stream, I call the draw cross-section method for each one of the points. So we don't actually draw the point that's in the center of the line. We take that point, and we and using that point in the direction to the next point, which is this, like the first point is the one at I, and then the other one is at I plus 1. And we use that to we take that direction, and we take the triple product of that direction. So the triple product is basically two cross products, one after the other. So it's like saying, like, take the cross product of the forward vector with the up vector, and then take the cross product of that against the up vector again. So then it basically gives you like a third, if the first vector is like this, and up vector is like so, this the result will be this. And then taking the cross product of that gives you another vector that kind of points like so. And this is exactly what we need for the first vertex of the cross section. So basically, just by taking this triple product and then the forward vector, we rotate around it using this angle axis thing to figure out the points, and then we can just here I'm really just drawing a line between those 2 points. But what we can do is turn this method, this draw cross section method, into something like the make catenary points method, and I'm just gonna write a new one. In fact, call it I think this one can actually also be static, and it's gonna be the make cross section points, and it's gonna take pretty much the same signature, I guess, as the draw cross section, and but instead of using it to draw a line, we're gonna use it to build up a list of points. So I think in the same way that we did the make catenary points, which takes a reference to an array, we can do that here. So I'm gonna, yeah, let's do that. So we have these, and then it has to be before the optional one. So another ref vector 3 array for the points that we're gonna load in. And then in this case, we actually don't need to do points 0 and 1 each time, because we're not actually doing, we're not actually drawing a line anymore. We're just, yeah, we're just filling out each point one by one. So we just need the 1, but then the loop here has to go up to exactly this value, I believe. Otherwise, it's going to be missing 1, right? No, wait. No, wait, I think we don't, because we can do this later in triangulation. So I think it's just this, really. So we basically start off at 0 and we load in the points. Yeah, points I is our point 0 there. So and then basically we return I, which is the number of vertices that we actually wrote, like so. Oh, return I. So yeah, I think that this will do. We don't need the I next anymore. We don't need this mod either. In fact, I can just do this. Yeah, and I think this is all there is to it. I might actually later add an offset to this I, because if I'm building up like an array of points, yeah, I'm thinking I'm actually gonna do that now. I offset, let's call it, and basically this will we'll use this to offset the array, like so, like points I plus I offset. So, and nothing else really changes. So this way we can, yeah, sorry. This way we can pass in a single array, and we will build up all of the points on this array, on the single array, like without having them stepping over one another. I think this will do. The one thing that I'm not a fan of with the array thing is that arrays kind of require you to know the size of the array in advance, and it's totally possible to calculate it, but it's a bit annoying. Like I could just use a list and add them sequentially. Well, that's great. Like I love hearing that sort of thing. Yeah, that's awesome. So yeah, so continuing with our thing, then I'm debating here whether to use a list and just make my life a bit easier, or just keep on going with the array. To be honest, the list is like the performance difference is negligible. So in fact, I am just gonna use a list. It's just easier for everybody. I'll just go with the list here. So list, and instead of going by index here, we just do add. And I think nothing else really changes. Yeah, the one thing is that using add, then we don't need the offset. Here we continue using the list. Here is also an add. Come on. And that's that. So that way we don't need to worry too much about the whole thing. And then a v point here, which is also an array of points. I can just it's a list. Oh, like there's 3. And I think that there is a thing where we set the capacity, so I could actually do like this, and it's kind of like a, I guess, like a suggestion, but let's not actually worry too much about that. And just so then we just need to change this type, and that's, I think, all there is to it. Saying there is an error here. So it's not length anymore, it's count, because this is now a list. So hopefully, if I did it right, we should have the exact same thing here. Yeah, I tend to prefer lists a lot more here as well. The array, I don't know why. I think it's kind of a procedural generation thing. Like you see, like, because meshes and triangles are all arrays with very like precise indices, like you sort of get, I guess, tempted to use the array instead of the list. But hey, hang on, what's this? Is this lag? Like, can you see that this is really not smooth? Like something made this like much worse in performance, and I know it can't possibly be the list. Although, well, let's see here. What did we do that could possibly be causing lag like this? It is struggling a little bit. So we did something weird because I mean, it's definitely not because we're adding stuff to a list, and we're not even calling the make cross section points here yet. So let me check here if I'm doing something untowards or something. Doesn't look like it. It might just be one of the many weirdnesses of Unity. So let's try recompiling this and seeing if, by just giving it another go. No, actually, it's still struggling a bit, which is super odd. Oh, I know what it might be, in fact. Oh, it's totally on me. It's my fault. I should have cleared this list. So I'm just basically growing this enormous list of points each time. And yeah. So one thing that I could do, though, is to not treat the list. So I did this once before. I'm actually, let's just keep it simple for now. Like they say, early optimization is the root of all evil. So so yeah, this is hopefully gonna be the cure for that. So I can't imagine how many times I was actually drawing this very same line here. Yeah, there we go. See, solved. So yeah. So we've successfully refactored it to use a list instead of an array. So that makes life a bit easier now, because we can, instead of calling the draw cross section method here, we can just load our list of points with our list of vertices. But then, oh, this is interesting. So yeah, we do need the list of points for each point of the spline. But we actually, I think we're going to need a second list, which is our actual vertex list, because they're not precisely the same thing, because we don't actually want the points on our list of vertices because they're in the middle of each of the cross sections. So here we're using the points list. But then for the cross sections, we're going to use the verts list. Yeah. So make cross section points. And this uses, well, it's the same call, isn't it? Effectively. Only in this case, we pass in our words list. And this also takes in a custom up vector, which I wasn't using. I'm not entirely sure if we need it. But I figured out that the up vector in the catenary equation, basically, well, we work it out here in the, no, not here, sorry. We work it out here, the up vector, which is normally just a global, like, world space up axis. And we use that to build our rotation frame, which, along with the forward vector, which is just the direction between point A and B. But the subvector, if you change it, it gives you a really interesting effect, which is effectively that of changing the gravity direction for the whole cable. And this is really cool because you can actually do some funky things. Now that I was gonna show it, I actually removed the one thing that lets us actually visualize it. I'm gonna bring this back just for now. And so by tweaking the up vector around, you can do some really interesting things that I think I want to keep because this is something that could be useful. Especially if we want to have this cable being used for something like an arrow tow line, like for towing up a glider and things like that. And if I tweak around here with the up vector, you can see that it basically displaces the line in a kind of neat way. This is a bit of a bug with the terrain thing, but let me just drag it up a little bit. And you can see here that if by just playing around with this, I can basically just offset where basically I guess the belly of it is, or if you look at it from the side, it swings. Like if we had wind or something, like this would be really cool to animate, like just a little bit, like so, to get the cable like flailing about a little bit in the wind. So so I thought this was kind of cool, but I digress, as you can see, right? So let's get on with making our cross-section points list. So basically, by the end of this loop, actually, we should have a proper list of vertices. So just to check that this is all working as intended, sorry, I will, let's go through the vertices and just draw them as little crosshairs in the world. So if that worked, we should be able to see our hexagons here replaced by little points. So what I plan to use this for, well, there's actually a number of use cases. But the first one when I use it for is actually to tie off balloons. And that's going to make more sense in a little bit. So there we go. The cross-section points are all here. Hopefully, actually, I'm going to try something real quick here. I'm going to reduce the alpha of this color by 0.4 or something, 2.4 actually. And if there's like a duplicate here, we're going to see one of these crosshairs being drawn slightly stronger than the others because they add up. I'm just doing this to check if there aren't any like extraneous vertices, and does it look about the same? I'm kind of looking at this guy, and I seem to kind of be able to see a 7th point here, I think. It's kind of easy to tell. We just go here and let's remove this +1. And let's see if this guy disappears, or if it just turns slightly fainter. There we go. See, there was a 7th point. So now it looks like we've got 6 vertices on each cross section, and or well, n sides vertices. So yeah. So basically these are our vertices. So this is all the vertices we're gonna need for the mesh. Compulsive saving, and let's carry on. So the drawing bit we don't actually need anymore. This bit here we can comment out. And now I just realized that this is all living inside the onDraw gizmos method. And it's now time to move this all out. So basically all of this, we're going to move up to the make mesh method, which we had up here. And let's get these guys up as well. The draw gizmos method, I'm just gonna leave it empty here for a while, and maybe keep this verts loop, but just comment it out for the time being. And this is just so that later on, if we need to, we can come back and visualize it. But hopefully we won't need so much drawing anymore. And in fact, this VP here is unused. We actually don't need it anymore. So we have the points, we have the cross sections, and then we have the vertices. So now we can actually go ahead and we don't even need this entire loop anymore, because we've already got our vertices. So next up, we need triangles to actually build up the mesh. So the triangles are it's basically an array with 3 times as many elements as there are vertices. I can just use a list again here, do the triangulation, and then spit it out as an array. That's going to cause a bit of memory garbage, but it's easier to work with, I think. Now, in fact, I think that in this case, you're probably good. I'm thinking, it's one of those things, right? You have to just go for one of them. It would be slightly more performant to just do an integer array here. I'll try and initialize it to, but if we do this after the fact, here, we know very well how many verts we have. We can just verts count times 3. And that's that. Like, this is the size of our triangles array. And then we just triangulate. So basically we do a for loop along the tries. But instead of going 1 by 1, we go 3 by 3. So that way we do no, in fact, I think we go 6 by 6 in this case, because that way we do like quads 1 at a time. So what we want to do here to get the triangulation right, and this is the bit that's going to be a bit of trial and error, and it always is, because the order in which you add the indices of each vertex defines which way the triangle is going to be facing. So if you get the order wrong, then the triangles go inside out. It gets really weird. So in our case here, we want to do quads between each cross section. So we're going to advance, I think, cross section by cross section, which is an offset of, well, it's an offset of 1 on the verts list and an offset of 6 on the triangles list. No, wait, is it? No. It's an offset of, oh, sorry, it's an offset of 6 on the vertices because each, sorry, 6 because I had 6 as my number of sides. It's actually an offset of n sides. So that's what it is. So the points on one cross section are always connected axially to other points n sides ahead of it in the list of vertices. So this loop has to stop early. It has to stop early by n sides times 3 elements, because we don't want the very last cross section, otherwise we'll run out of bounds when we do this. Hopefully this is correct. So then we go price, we begin at I, which is the first point. So these are essentially indices to the vertex thing. So the first one is really just the first one. So this one is basically, I guess 0 or maybe I plus 0. The second one, so I plus 1 here. I do believe we're going to need a new integer here for the cross section or the verts, actually. So this is where it gets slightly confusing always. So it's vertex like 0, 1, 2, right? You know what? It shouldn't be going over the vertices. This is going to be easier if I just go by as many verts as we have. Increment I normally by 1. And for the triangles, we just do, we just assume that this list can hold 3 times as many elements. So if we do it like that, then yeah. Yeah, and then we can do like I times 3 for these guys, because then I times 3 is the index of the beginning of each vertexes triangle. I think that this will, yeah, this is easier to think about than with, than it would be with that, with division operators, which we would have to do if we had the, if we were doing this the other way around. So what I want to do is, now we have one triangle per vertex here already. It's gonna do like, it's gonna do half the mesh. So what I want to do is to just create the mesh, or grab it here from the mesh filter, and just so we're gonna start here by creating a new mesh. I can do it in the bottom here. So mesh is a new mesh, or actually this could be moved up to up here. You don't actually need to like declare this again and again, and just clear the mesh with whatever it has. Then we assign the vertices, which is our verts, to array because they're a list. And then for the triangles, we do the same. Triangles is triangle. Then there is, I think, an apply method or recalculate bounds or something. Recalculate bounds and I guess recalculate normals as well because we don't really, and recalculate tangents because we don't really need to do anything different. Like these are the standard Unity solutions for that kind of thing. So by doing this, we can now, we could do this on update, I guess, and just, yeah. So if we have like a proper reference to the mesh filter, oh, come on. So if the mesh filter, oh, because MF is a template that's expanding, it's not null, then we make the mesh. I did tell you that there was going to be a lot of typos, didn't I? It sucks. It's this keyboard. It's got like linear cherry red switches on it, and they're super light. And I keep making typos, and it drives me nuts. I've actually already ordered a pack of cherry grays, which are much nicer than these guys. And they, I don't know if you can. Yeah, it's. I actually had to buy like a sampler kit because how do you buy these things online? Like without knowing how they feel. So I chose the grays and I ordered a pack of them, and I'm gonna rebuild this keyboard with all Cherry MX gray switches. Hopefully, it's gonna make me a better typer because yeah, it's been over a year now and it's driving me nuts. So yeah, let's carry on. Rant over. So we're making the mesh now on update, and hopefully, if this goes well, we should see, well, something. Or if we don't, well, we'll know hopefully how far we can go. Or get an error. That's always an option. So we have no reference, so something is missing. What did we forget to do here? Oh, nothing here is null. It's on 107. 107. Oh, it's doing stuff to the mesh. Oh, didn't we build a mesh already? Oh, that's weird. Oh, yeah. So you know what I'm gonna do? I'm gonna let's make this slightly linear. And I'm gonna kind of do the same thing here for the mesh. Just the same way. If the mesh is null, then mesh is new mesh. And we just kind of treat it as if it were like a list or an array. Because it kind of has the same. So that should give us a valid mesh, hopefully. Anytime now, you don't need. The big trouble is that I'm doing this on the main project, and the main project has like an enormous chunk of code in it. Internal create is not allowed to be called from a behavior constructor. Call in a wake or start. Wait, what? On the game object cable. Where did I call a constructor on this thing? Oh, yeah, here. Okay. All right, still no mesh. Still some errors. But I'm not entirely sure what it's doing. Oh yeah. Well, we have the mesh. We never actually assigned it to the mesh filter, did we? So I'm not a fan of like if this thing doesn't have any references to the mesh filter, I'm not a fan of adding one here because that will make this entire method less portable later. So what I'm gonna do is have this out the mesh or something. Yeah. And so that way we're actually here we're not working with that mesh, we're working with a parameter. So, oh sorry, it's a ref. It can't be out if we are reading it before we do anything. So yeah. So that way the mesh in here is just a parameter and this entire method is still portable if we wanted to make it, well, other than these three fields here that it's referencing, but that puts the mesh like up here. It's not part of the stuff that the code below is using. So then we have the mesh, and here that we have already a coupling to mesh filter. We can assign the mesh to it, and yeah, we'll see how this does. In fact, we could actually even initialize the mesh as the one in the mesh filter, but if it starts off null, we can't, right? So we should see some magenta, hopefully. Or, well, I don't know if the material is already assigned. And we have nothing. But we also have no errors, so that's at least some progress. Oh, hang on, it's over there. Yeah, sorry, I forgot to convert the... Ooh, there we go. So this doesn't look at all like what I was expecting, but it did something. So we're building up the mesh. So, yeah. So this is my way of doing it. I just do whatever I think might work, and then I see how badly it fails, and then I fix it until it works. I guess that might be a lot of people's ways of doing it. So basically, we were drawing world space points, but meshes are in, in local space. So what we need to do is take this verts array here that we have, which is all in world space, and convert it to the transform that we want. So one way to do this would be to do it inside the method, pass it the transform, or we could just do it here in this method. I'm gonna take in a transform because it needs to be at least here. Transform mesh. Yeah, so we know that this is the transform for the mesh. And then we could do it here after the make cross section points. So it spits out world space points, and then we that work. Now I'm gonna pass it in. Let's stop being lazy. So inside references verts and then mesh transform mesh and add this parameter. Oh, I guess there was another vector. I'm just gonna pass the vector 3 up, which is I think what it was doing already. So add parameter, and then down here we get our transform mesh thing. So instead of just adding 0.0 directly, we can use the transform mesh to I think it's inverse transform point. Yeah. So that way all of our points are in local space. So that should at least bring the chain back to here. Or well, no. Oh, because I never actually added it here. So it's the same transform as this part at the moment. Or in fact, if it's not, we'll just do this. Grab it from the mesh filter. So that way, if we move this script elsewhere at some point later, it won't matter. So after the obligatory period of waiting for it to finish compiling, we should see something different. Or not. Okay. So that did nothing, actually. Points are still over here, which is strange. So give it the transform. The transfer goes all the way in here to the cross-section points. Oh, you know what? The cross-section points should already be in local space. Like the points should already be in local space, I would think. So instead of doing that, yeah, I'm not going to do this. In fact, I'm going to, let's remove this bit from here, because this entire bit here is very much coordinate frame agnostic to an extent. Or at least it doesn't really care what coordinate frame it's in, as long as yeah, it doesn't really care what coordinate frame it's in, because everything that it needs is coming into it as parameters. So here there's only there's one assumption about the coordinate frame, but only if I don't specify it, which is fine because I am. So here, and the make catenary points one is, well, it's not the same thing, because this one really does take in world space positions. But, so that's the thing. What I think I could do is to just, instead of using these points here directly, I'm gonna transform them here. So the points array will be in world space, but when we make the cross sections, we will make cross sections in local space. So R0, I guess, that's another snippet, is our mesh transform. Invert the first point, and R1 is the next one. So then we just pass in R0 and R1 to this, and here, instead of passing in the vector 3 up, we actually also have to convert relative up is ref mesh inverse transform direction world space up, I guess, which is what we already had, and then we just feed that in here. So that way, oh sorry, relative up. All the cross sections are already in local space. So then by the time we build up the vertices, it should all be in the proper coordinate space for the mesh, hopefully. So we'll see. Yeah, there we go. At least it's back to the correct location. So now we have the mesh, and it draws, and it does a horrible job of assigning triangles, but it does it in the right location. So all we need to figure out now is the ordering of the triangles, because we already have the whole the life cycle of the thing. So let's get back to our triangulation bit. So what we're doing here is completely wrong, because we don't want to triangulate each vertex to the next vertex in the list, because the next vertex in the list is, so imagine you have the first cross section here, and there's another here. The vertex 1 is here, vertex 2 is here, and vertex 3 is here. Neither of them are here, and what we want to do is do 0, 1, 2, and then, so the third point of the triangle really is the second one, but this one is the first one of the next cross section. So this one is n sides away in the linear list of vertices. Yeah. And then we will do the other side of the quad, which is this, we can do it, so 1, 2, 3, and we can do, I guess, 2, 4, 3, I guess. So we start with this point as the first one of our triangle. Then we go over to the next one. Then we go back to the first one. And if I did this right, we should have a quad. Although I believe we're going to need to do some more iterations here, possibly. We'll see. Or we go out of bounds completely. That's another option. Yeah. Oh, this is nice. This is new. I recently upgraded to Unity 2019. I was on 2018 for a while. And the out of bounds exception before used to be much less informative. Like, well, it doesn't really tell me. So the index count is 915. The vertex count is 305, which is, I guess, correct. So some indices are referencing out of bounds vertices. So then I might be going beyond what I need here. And yeah, we definitely are, I think. At the very least by 1. So we're gonna try that. If that doesn't work, I might have to use the debugger and see where it is or how far it's trying to go. So let's see. No, that kind of did it. All right. So we have something. First of all, we're winding the wrong way around, but it's already starting to look like something. So this is oh, sorry. Of course. This one should be +3 +4 +5. And the other thing is that it should be the other way around. So this is 2 and this is 1. This is 5 and this is 4. So we wind it counterclockwise. See something that looks slightly more promising this time. And well, at least it's the right side out this time. But the very first one here does seem to be correct, which means that we're getting there. Like we have one quad here that drew as you would expect it. The other one's not so much, but this one worked. So let's see then, what am I missing? Let's see how this behaves if I change the number of sides and stuff. 6, 7. It's not bad. It's behaving kind of as expected to that. But yeah, here we've got some funkiness going on. But we'll get that fixed. The normals are all messed up. Anyhow, let's see. So I mean, this has to be okay, right? Like we're doing 6 vertices at a time. And we're not actually running into the, we're not running out of range on the triangles array, which is good. So then, oh, wait. So, oh no, wait, this is correct. But wait, not quite. On 1 plus n sides is 1, 2, 3. Okay. So then it should be 2, 4, 3, right? So this 1, 2, 3, 2, 4, 3, right? So 2, 4. Yeah, so and then oh no, yeah, sorry. So 2 is I plus 1, 4 is this, and then 3 is this. Let's see if that does. Huh, no difference at all? Wow. Oh, that sucks. What am I doing wrong here? Maybe we should go by cross section on this. Hmm. I'm gonna remove the second face here and just see if the first face is correct. Because I'm seeing something here that is a bit weird. I'm gonna see which one the first face is. Oh, okay. So hang on. Oh, we were looking at it the wrong way around. This is the first side. Okay, and that's more along the lines of what I expected. So we have triangles here, like from 0, 1, and n sides ahead, which is correct. And then, you know what? This might be a bit of a cheat, but I don't really. Let's just make life easier and not actually care what the index of each triangle is. We really just want to wind it, so we just add instead. So let's add I plus 1, I plus n sides. And here we spit it out to an array. And well, this I think we should do probably the same as we did this. Why is it complaining at me? Oh, this makes no sense. Oh. Could it be? Yeah, it is. All right, so we just push triangles now instead of worrying about where they actually go. They go in sequence and we don't actually care beyond that. So this is just to make sure that we're doing okay. Looks okay. So then we can do the other side without having to worry about the rest of it. So the next part is, well, the second phase. So we start from the second one. We go to the other side. Which should be this, and then we wind back to its neighbor, which should be like so. Second one, other side, and the neighbor. There we go. To be honest, I don't know where I was messing this up before, but now we have a proper quad mesh that goes all the way around and has continuous normals, which is great. Now we can play around with the number of sides and stuff like that, and we are properly extruding a bit of cross-section mesh, except for this very last guy, which I believe might be our -1 here that we actually left out. So let's try removing it now and see if this breaks everything or if we actually fix the very last missing bit. Now we break everything. Okay. That's also fun. So why are we missing that very last face? This is super annoying because, like, I mean, why? One face. It's one face. It's not two faces. It's just the one. Which is kind of inexplicable. Like, why? We're doing two faces at a time here. Like, how is this even a thing? Like, it's one triangle. It's not the entire quad. Like, for this to be missing, it's like saying that this here is like I should be seeing like a hole in each one of the cross sections, but we're not. Oh wait, hang on. There we go. Oh, I see what's happening. We never completed the first loop, I guess, for some odd reason. So hang on. So if this here was the first phase, we go like 0, 1, 2, 2, 4, 3, or whatever that is, and we go all the way around. But we miss the last side. I mean, this is mysterious, I guess to say the least. It could be because we have, well, right now we have 6 sides, but we actually should have 7 faces. Wait, that made no sense, did it? Well, no, we should have 6 faces. 1, 2, 3, 4, 5, 6, yeah. So how is what I'm wondering. I wonder though, because I think I'm getting ahead of myself here, like, because we never go back to the first one. So we need to have at least 2 shared vertices, and we do have two shared vertices here. But I guess I'm using the wrong one, possibly. So I'm doing I plus 1, which I reckon is to the side, and then 1 ahead. You know what I'm going to do? I'm going to do 1, 2, 4. So this is going to invert the side of the triangles. And then 1, sorry, yeah, 1, 4, 3, I guess. So that would be 1, 2, 4, and 1, 4, 3, which is the one that ends sides. We'll see what this does. I find it weird that just changing the winding order could actually fix something like that, but I've seen weirder things, I guess. And well, the triangulation did flip, but we're still missing the last guy. Oh no, wait, we're doing something funky here. Oh, we've gotten ahead of ourselves, look. Like we went out of the cross section. Okay, so this is fun. We're starting to get somewhere, I think. So then, well, this is super weird because like we made the cross-section points one by one and we added them sequentially, like cross-section by cross-section here. And there's, I mean, the list is correct. We don't have any surplus or missing vertices. And we go from 0 to n sides on each. Oh, we go from 0 to n sides, right? So 1 plus n sides, at least on the first run, is the last vertex, not the next vertex on the other side. So it should be this, actually. It's plus 2 because n sides, because this is from 0. Did that make any sense? Now we're out of bounds again. Okay. Maybe insides minus 2. Let's see what that does. Ooh, oh, that's funky. Wow. Okay. That's, I was not expecting this. It's a very interesting arrangement. And we are still mysteriously missing the very last triangle. But you see how, because I honestly don't think we're missing that triangle. I think it is here, but it's somewhere else. Like, see that here we have a triangle going off to a direction that's not the same as the others. It's the only one, apparently, for each one of the, there's always one that's bad, I think. So I think we do have the right amount, but we are actually, I guess, doing this somehow incorrectly. So we'll see. I think I see what's going on here. We do really want to get to the very end of the list. At least if we're going, well, at least one cross section up to the very end of the list. But we should But we have to be careful here because we don't ever want to go beyond n sides, because then at the very last run we're going to overflow. We're going to go out of bounds if we do n sides plus 1 here or anything like that. So n sides has to be the highest offset. I do have a mesh for twisted steel cable. So let's do it like this. And so then if we don't start from the very first vertex, we can go back a little bit. And I think we could do that and start maybe from vertex 1 or something. And then we start from I minus 1, which is vertex 0 now. Go to I, then I plus n sides. So this looks okay. Then go to I again, which is then I plus n sides. No, wait. This guy is minus 1 again. Dun, 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 dun. Yeah. And then I plus n sides minus 1. So we don't ever go out of the thing. We just make basically constrain our loop to iterate over, I guess, a saner range. I don't know. There we go. So we're back to having a proper mesh. We're still missing that annoying last bit here, which I think is where, oh, I think I see what the problem is. There's going to be a point where we need to go back to 0 effectively. Like there's one location along the so yeah, actually none of this that I did here is well, I guess this is good to just constrain the whole thing to so we don't have to add like minus ones this here or anything like that. We're inside like a known bound. But so basically what I think is the thing is that we will get to a point here inside this this thing where one of our vertices, like our neighbor vertex, will actually have to be the first vertex of the cross section we are in, because it's coming back around. So imagine like we've gotten to like vertex 5 and the next one in the triangulation is not 6, it's 0 again. So hang on, I'm gonna make this easier on myself again. But I think I've got it figured out now. I think I've worked out where the like where the rogue thing is. And just for just to check here, I think that just to make sure that I didn't break anything by making that change. It's always something. What the hell is this? Wow. Wait, but hang on. Oh, okay, I see what happened. I can see triangles on the inside and the outside. So just wound one of them the other way around. Should be something more like that, I guess. But what's happening is that at each loop of at each loop of quads, I need to take a mod operator of some sort. Something. Still not quite there, am I? This is I plus 1 as well. So yeah, welcome to procedural generation. This is a lot of recompiling and seeing what it does, and trying to get the triangle indices right. Okay, there we go. Finally. So so here, see, like this, we probably have a triangle hiding out somewhere. Here, like I'm not sure. I think that it might be a triangle, like a really thin one, like going across like so or something. Um, or it might actually be completely invisible because it's doing like 1, 2, 3 or something like that. So what we needed to do is to there needs to be a mod operator, like a mod 6 or something like that here, somewhere. So I think what I want to do is and it's this guy. It's this it's the +1 guy, because we go like 0, 1, other side, then 1, other side, +1, other side. Also, there's 2 actually. So that +1 has to be, I guess, clamped to the cross-section index. You know what I mean? Like if we're at the last vertex of a cross-section, we have to make sure that when we do +1 here, we don't go to the next row, we wrap around. So how can we do that? So what I think we can do is oh, I think I know. We do I+1 mod and sides. So this will give us a value that is sorry. So this will give us a value that is between 0 and n sides. And then we add the number of, well, basically the offset again, which is supposed to be an int division. This is all int, so it should be fine. So it's I divided by n sides, I think. Or something like that. Or is it I times n sides? Oh, hello. So Balsa it's coming along. It's been working on it every day. This here is part of it. And yeah, hopefully we're not too far off. I know I've been saying that a lot. But I do know that it's gonna happen this year. That much I can pretty much confirm, because yeah, because of reasons beyond my control, the game will release this year, for better or worse. But we're making steady progress. I mean, we are. We've made a lot of really big changes to Balsa since the first since the demo that we did on the Steam Festival back last year, and we learned a lot of stuff from that. And from that, we actually came up with a huge number of things that we wanted to change in the game based on feedback. So since that time, around like September last year, and now we've been working like pretty much nonstop on making these changes. So that inevitably added to the schedule, because that was that wasn't originally part of the plan. But the game feels very different now, and it's got like a number of really cool new things that nobody's actually seen so far. and hopefully I'm gonna get to show it off here in not very long. So yeah. So yeah, sorry. I'm just here trying to figure this thing out. As for the KSP2 dev team and how much communication, I have a total of zero communication with them. Like they've actually never reached out to me, never got in touch in any way. Um, like, to be honest, I know just about as much, probably less than most of you guys on how that's going. So, like, all I know is what is available, like, on the internet. Like, I'm pretty much just like anybody else for that. Like, the rest is speculation and gossip, really. So, so no, I haven't had the chance to give any sort of advice or tips, and uh, it's questionable how welcome that kind of thing would be. I mean, it's not a um, like it, I guess it would be weird. I don't know. Yeah, I mean, I've thought that at some points, and at other points, I thought like it would be. I'm actually glad that it's progressing on its own, and I get to just do my own thing. But it comes and goes. Depends on the day, I guess. It's a weird feeling. Um, it's weird. Like it's something that you worked on and you created, like, and then you see like a whole other group of people working on it. It's a weird feeling, and I reckon it must happen a lot with games in general. But yeah, I mean, I can only wish them best of luck, I guess, and I guess just be glad that I get to work on my own thing. Yeah, and so then, so what I was trying to do here is that oh, I don't need to do this. So we know that I is the first vertex. So yeah, if we think about it in terms of like starting from I, then it's this, like it's the first vertex of the row plus the next vertex, but clamped so that it goes around. So that way, so it's never just, I guess, plus one. It's always something like so. So then, yeah. So if I did this right, we should have a that missing face here, hopefully. No, we are out of bounds again. Come on. What am I doing wrong here? So I borked something. Um, plus I plus one mod n sides should be correct. Then, oh, you know what? I think here we don't do that. Or do we? And how did I go out of bounds in this? So I do have a Twitch channel. Um, I actually was using it yesterday. I decided to try out YouTube and see how that went because mainly because I have more subscribers on YouTube than I do on Twitch. Um, I don't know what the general preference is though. Like if is it like a thing that everybody prefers to watch live streams on Twitch instead of YouTube? Like to be honest, I could just do either. It's equally uh, it's the same amount of effort. I just think that I don't know, I'm more used to doing stuff on YouTube, I guess. Or rather, I'm more active on YouTube normally, just with my own account, than I am on Twitch on any given day. So yeah, I reckon I would tend to lean towards going to YouTube more on, on that aspect alone, I guess. So, so then back to this part here. Like, why are we going out of bounds? Like, why is... Oh, wait, hang on. It's here. So this is completely incorrect. It should be like it's n. Oh, I know what's happening. So it should just be plus science plus science. I'm not sure if it's this. So what I'm trying to do here is to make this thing all the way around. I do think that maybe this one might not need it because we were going okay, and I have a sneaking suspicion that this is the face that was okay. Balsa Model Sim iteration and something more global. It very well might be. It Oh wow, that's messed up in an entirely new way. So Balsa is what I like to call it as not a second step after KSP. It's more like a new first step because as you know, like after I left KSP, I had to start all over again on my own with an entirely new dev studio, and basically I had to start again from scratch. So Balsa was a project that I felt I could do without having like the team that we had for KSP. And effectively, I started off working in Balsa on my own. So it was a project that I wanted to do, and and it felt like something that I could do, even if I was just by myself doing it. So so yeah. So my Twitch channel name is KSP HarvesteR, I think. Um, should be able to find me, hopefully. So yeah, so Balsa is really like a new first step for me. It's a project that I started doing and had to be scoped so that it would be like conceivable that a single human could actually carry it through for the most part. So I've been uh, the dev side, the dev team for Balsa. It's been really just me and one other developer for the most of the project. Now it's just me again because we got to a point where uh, his workload was really low, and mine was like spiraling out of control because he was just working on assets, and I'm doing all of the programming and development and UI and the rest of it. So what I so then it became just me, and I'm now actually looking for to take on other people to help me with the game design side, to write missions, write content balance, create like stock vehicles, stuff like that, and hopefully that's gonna happen in the very near future, and we're gonna see like a little boost in yeah, a little boost in what could you call it, productivity, I guess. So yeah, what I would like to do is to just like dual stream. Um, but to do that, I've looked up. I remember looking at how to do dual streaming like a long time ago, and if I remember right, it was a paid service, and it was actually a pretty expensive one as well to just stream to two platforms. So we'll see. I guess I might try streaming to Twitch again on the next one and see what but I do think that I mean we're all here, right? Like it's not as if like there were no overlap between the Twitch and YouTube communities. Um, but yeah, if there are free ways to dual stream, I'll have to look at that again. If I find something, then that's the ideal thing to do, and then that's the best of both worlds, literally. But uh, but yeah, today we're here, and I am quite close, I think, to sorting this out. I've seen EJ. Oh, Das, yeah. Actually, no Das personally. He came up to the KSP office once. We actually did a live stream together. So yeah, let's see here. So I did something very messed up. Insights and plus insights plus one, and back to plus n sides, which is mm, mm, mm. Oh no, it's like this, and then plus one, plus n sides plus one. And could it be? Oh, hang on. Plus n sides plus this. Then back to plus n sides. Like this should be the correct thing. Yeah, that would be really cool to do like a convention or a booth. A booth is a lot of work, I know from experience. But doing like a talk or a convention would be pretty cool. How is this going out of bounds though? Like, how is this possibly going more out of bounds by having the mod operators in than it could have been otherwise? Yeah, it's not a plus two thing. It's I really just messed this bit up quite badly. So we worked out that if I do this, I basically start from I, and the mod thing will make this number wrap back to zero when it goes beyond the number of sides. Yeah, he came down to Mexico City once. I don't remember when that was. It was quite a while back. But yeah, he went down to the squad office. So what I need to do here is I need to mod after adding it to I. No, if I do that, I'm gonna stay in the first cross section always. So, oh, hang on. But you have something there. I is not the index of um is it's not the beginning of the cross section. Well, not always, at least. You know what I'm gonna do? I'm gonna go through this, I think, 6 by 6 and do a I'm gonna do a conditional here because this it's gonna be too much of a hassle to do um, this expression in a generic way. So basically, this is the standard form for it. So if I mod n sides is sorry, this is not mod. Like if I mod n sides is anything that isn't like n sides minus 1, which is the last one, then this is our triangulation strategy. And then we just do a different one where we know to wind back instead of advancing. So instead of doing +1 here, we do I minus n sides minus 1, I think. Because what we want to do is, say if we're at vertex 5 out of 6, when we get to 6, we want to do 7 instead. No, we want to do 0 instead. This is what I, so, yeah. So it's the same here, because it's the same vertex. And this guy also, instead of going +1, wraps back to n sides minus 1. And this only happens at the very last quad. Yeah. Oh, there we go. See? I believe we have worked it out. Yes. We're missing one full quad here, which is actually not bad because we had this -1 thingy happening here. And the -1 no longer applies because we're gonna be at this strategy on the very last one. I could maybe do it with the modulus statement, but like it's a lot of extra maths for something. There we go, finally. Got it. So it's a lot of extra maths for something that is only going to be used at the very last row. So the if statement in this case is actually more efficient if you think about how many calculations you're doing per quad. Because then on the very last one, you go into this other code path, and like we don't have any division operators inside here. So this is ever so slightly more efficient. So we have all the triangles we need now for the entire catenary. We just need to do the caps now. And the caps we can do as a simple fan. I think we just do like on the very first cross section and the very last one, we fan out to do the caps. So, and this is very so basically just do like from 1 to n sides, we do triangles add the first one to the second one. Actually, we can actually begin from 1 here, I think. I'm mistaken. Can we? Wait. So this is a triangle fan. So all of them are gonna go back to that first vertex. So it's oh, you know what? No, I need to do like 0 to n sides. And this here only actually works if it's from 0, like it's going like 0 plus I, 0 plus I plus 1, and like the other one is just 0. So this is the fan, but we replace this 0 with the index of the first vertex of the cap, which for the first cap actually is 0. But for the very last one, it's the first vertex of the last cross section. So I guess we could just keep this because the first cap is always going to be this, and then the other one is, let's see, the last cap is at verts count, right? Or n verts. Minus n sides, I believe. -1 possibly. Or verts count -1, which is the last index, minus n sides. Yeah. So these are the caps, if I did it right. We should have like a little triangle fan, like capping off the catenary. There we go. Or, well, something. I guess I got it wrong. Yeah, it's definitely wrong. It should be here. Hello, I am doing well, thanks. And here, maybe we wound it the other way. Yeah, we got it right, we wound it the other way around. So, interesting. A 6 side, but we only actually needed 4 fans to do this. So I actually can get rid of the last one. So it's n sides -1 to do the cap. Or actually, if I'm not mistaken, we would start at 1. And then go 0, 1, 2. Something like that, I guess. We'll see. But this is backwards, so it's like so. Wow, 10 concurrent viewers. That's a new record. Hooray! What color YouTube button do you think I get for this? So there we go, triangle fan on the first cap. On the last one, well, we still have to do this one proper. I think that for this one, we don't actually need the n sides if we start from the last one and then subtract I as we go. Right, so again, we start from 1. So if we go backwards here, like so, it kind of works in the same way. Oh, hi, Sir John. I know who's here. So yeah, what I'm working on is a procedural catenary, or basically a rope-like curve. So we got this working, just need to flip it. And that is the last poke, I guess, at the triangle. And I believe we have our procedural catenary. So to give you a more proper explanation of what it is I'm doing here, yes, there we go. I just did this. So we have a procedural cable of customizable thickness, number of sides and segments that connects one point to another point. And my plan is to use this for anything that needs to be connected by some form of rope type thing. And this doesn't use interconnected rigid bodies. So it's basically just it's a convincing like representation of a rope that doesn't require us to do like a chain of rigid bodies. It's a catenary curve. So, and there's another thing that it's also able to do, which is to conform to terrain. Like when it drops, it will actually conform to the terrain like this. It might actually need a few more segments here. Yeah, 13 is quite few. But if we give it like 32 or something. So the way this works is it basically finds the surface and clamps the rope to it. And we have a very nice, like very organic looking long boy. Yeah. Wee. So yeah, I thought about doing power lines with this because like we don't have to, like right now I'm updating the mesh on update, but I don't actually have to. I mean, I could to do like scenery stuff, I could just do a version of this that is basically offline, like it resolves itself once and stays. Because this here is actually doing a fair bit of maths, I would guess, to like for something that isn't for something like as um, like small in terms of detail and high in terms of like population as power cables. But it could be something like with the right amount of like LOD like optimization, we could actually do something like that. And yeah, the reason I wanted to have this is because there is something that I want to use this for already. And in fact, I think this is really at a point where I'm actually able to show it and actually use it for something. So let's make this a prefab. I'm not sure if you can see my, I probably can't. I have the project view here on the other, beyond the screen. And I'm gonna make this into a prefab that I can reuse in places. I'm just trying to figure out the best place to put it in. Like for instance, they have this geotex runway thing. It's just kind of here. Oh, okay. So yeah, I could just put it there, I guess. Like this isn't really a prop, but it's either that or it's gonna have to go in an entirely new folder all of its own. Yeah, let's just call it a prop or a prop-like thing. I just want to make it a prefab. Cool. So, all right, have a good one. So I will, let's go back, let's get out of the test scene now and into, well, the test scene. Like this is just the test for the cable. I have a test scene that is actually the Balsa test scene, which is where I do most of the development for the game. And we can actually put this to some use already. I'm really happy to have this. Like this is I was wanting to make this catenary thing for quite a while. So this here is the test scene, the Balsa test scene. So I use this to test out the game without having to load the scenery, because the scenery takes a fair amount of time to finish loading. And with this scene, I can just hit play and I don't have to go through the main menu or anything like that. I just hit play and I'm immediately in the game. And I also have this test scene logic script where I can configure all sorts of like automatic start situations for myself, like automatically start in editor mode, start with the game manual already up, start with the scenario editor already up, like draw debug stuff, already automatically even start the engines, place an action figure, and even throw the airplane if I wanted to, depending on what I'm doing. So it's pretty cool because it saves me a lot of time. So here we have like a balloon, or well, a blimp, and this guy is the sort of thing that I was hoping to use the tether line for. So in fact, I have a oh yeah, this is the correct prefab actually. So I don't actually have a way to find the ground from this guy just yet, because one of the ends is going to be connected to the balloon. The other one is going to be connected to the ground. Right, so if the full thing looks like this. There's it carries a gate that you fly through. And these are, this is the prefab for a side mission gate. So basically, when you have side missions in the game, you're going to see these balloons around the map. And by flying through them, you start the side mission. So I wanted to add the tether line here to actually well, connect the balloon to so I'm just gonna drop it here next to the model, I guess, and connect both ends. So one of the ends is, well, the model proper, or I actually could if I wanted to connect to something like right here, because this whole thing is kind of like bobbing back and forth. So what I'm gonna do instead is actually connect it to uh, an anchor object that I'm gonna drop inside here. Hello. This is in the map objects layer. And see, we have this thing here. I'm gonna drop it. This transform will always be anchored to it. So the cable can now use this as point A, I reckon. I can make this a part of the prefab as well. So now I can actually tether it proper. And then I need to have a second anchor, which I'm just gonna, I guess, have here at some point. Tether anchor, ground tether anchor. And this guy has to go like at ground level, which I'm just gonna set like manually for now, I think, because right now I don't really have a way to and just reset stuff here. Let's do like -40 or something. Later I'm gonna have to raycast down from this to the ground, find where the surface is, and then put the tether anchor there. But for now I'm just gonna keep it like so. And there we go, we have our tether line, and it now runs itself into the ground. That's weird, isn't it? Oh, I think it's because it's actually finding the surface. Like it's raycasting and finding the surface and it twists or something like that. But yeah, so there we go. But this, the cable isn't long enough, I think. I need to make it much longer. There we go. So if I make it like, it should only be like as long as it needs to be to keep the balloon up there. Oh, 0.16 is very thick for this. 0.05 maybe. Yeah. I don't know how this is gonna look, to be honest, but I guess we'll find out. If this looks too weird, I can change where I have the tether anchored to. But all right, we can save that. I think that there's some unapplied stuff here. Apply that. Apply this. And give it a go. And hopefully we'll have our balloons tethered to the ground, and that should hopefully explain why they don't just drift off with the wind. So I hit play, and that's what I'm waiting for right now. Hey, 11 viewers, that's a new record. So there we go, the game has started. Oh yeah, I should mention other balloons appear every now and then. But yeah, there we go, see? It's actually like tugging on the line and you can see it doing it. There we go. Doink. Nice. Yeah, I'm quite pleased with that actually. I might drop the number of sides that this thing has just to make it slightly more efficient, because like we don't actually need 6 or 7 sides for a cable that's just this big. But there we go. I'm pretty happy with that. Oh yes, I know. My plan is to do this kind of thing much more often now. Yeah. So there we go. So I'm actually this is the first time you're seeing a lot of new features that we've added to Balsa since the demo. You can probably see here, like there's a lot of stuff that wasn't in the demo. Like for one thing, we have these. Well, we have many things. So we have procedural runways that you can land at to get resupplied, like to resupply your vehicle. You actually have a transport. This is your car. And your car gives you two features. Now, one of them, if you go to the trunk, you can interact with it and manage your vehicle. So I don't have any on this save because this is a new career that I started. But if I go, say, to the build tent here, and oh, hang on, I need to do a thing to stop the spam of no reference exceptions. It's just an editor thing, it's not a game bug. And let's not build one from scratch. Oh, there we go. Yeah, the Delta Wing thing too. This is one guy. So, so I have my plane here with me. You can manage your planes from this the vehicle, so I can put it away here by looking at it. Where is it now? So, no. Oh well, it didn't want to, I guess. I can put it away by clicking here, but it's too far away, so it's gonna tell me that if I put it away, it will be left behind, and my choices then are to recover the plane or abandon it, or I can just go. So VR is in fact very much a thing. There we go. Put away. It's interfering because I have the plane in hand. So if I put it away, it goes away. But if I click, I can interact with the trunk of the car and select vehicles to use. I can also put it back and go to the door, and going to the door I can fast travel, and fast travel lets you get quickly from one part of the map to another, like so. And then at this new location I can pick up the plane and fly it from here. And flying the vehicle from places is important because we now have a limited transmitter range, which is very much as it should be for model vehicles. So you can pick up the plane, fly it, and if you start going out of signal range, you will start to lose signal quality, and eventually you will lose control completely. So where you fly it from as the player is pretty important, because there's areas of the map that you just can't fly to if your transmitter can't reach there. So in the test scene is pretty small. So wherever you are, you're likely to cover most of it anyway. But so then these guys, these balloons, you can fly through them, and this one is the prefab, so it doesn't actually do anything. You can see that that red one down there is actually tied to a mission. So if I fly through it, the balloon goes away, and then the mission has started. The mission here is just a test where I fly through the waypoints. And after I'm done flying through the waypoints, the mission completes and other side missions appear, like this one. It says you're meant to fly through the hangar, but it's really just a test, and it just completes itself after 5 seconds. But yeah. So yes, there are gonna be upgrades throughout the campaign. Upgrading the transmitter is definitely one of them. But in fact, there are a number of things that get upgraded in career mode. This is one of the things that we've been working on a lot since the demo, and we've put in a lot of work into making the career basically a more well-rounded gameplay mode. And a lot of this is based on feedback. So for instance, back with the demo, you didn't have a way to get around the map properly unless you walked on foot. So when you were playing like in multiplayer and stuff like that, it was really difficult to like meet up with other people because you had to go around the map on foot. And there are areas of the maps, on some of the maps, that just aren't accessible on foot. Like if you wanted to get to well, this test scene doesn't have any, but like assume that if we didn't have like this bridge here and I wanted to get to the island, if you were on foot, you just couldn't do it. But with the fast travel lets you go places by just using your vehicle. So oh, I can't put it away here because the vehicle is now all the way out there, just at the very edge of signal range. You can see that on the minimap. If I go much further out that way, I'm gonna start losing signal quality. And actually try. Like if I fly out beyond this yellow line, we'll see that you start getting static. And if I fly beyond the red line, you can see that on the UI there, that the range signal is dropping fast. If I fly beyond the red line, I will lose control completely. And I rather like this plane. I would rather not do that to it because it's just gonna fly away on you. And then, well, you may be able to recover, or maybe not. Another thing that's changed from the demo, and this one I can show because I have the developer tools enabled. So if I crash, like so, and well, I'm gonna have to go like in the car and like travel to wherever the vehicle is and try to well, go to it effectively. So there it is. And well, it's in pieces. But as I approach the vehicle, I now have this actions options. And one of the options is to send it off for repairs. So one thing is that in career mode, you can't just freely repair stuff anymore like this. So in career, repairs will cost you time and possibly later funds as well. The back to workshop button here should actually not be available just now. It should be grayed out because the plane is broken. If I go back to the workshop, it's going to fix itself. Or actually I need to revise the rules for this one button. But if I choose to repair, it's going to show me why it's taking so long. And it's because it's got 13 broken parts in it. So it's going to be 10 minutes before it can be available again. So if I hit recover, it's sent off for repairs, and I will get to fly it again in 10 minutes. So that's where your other vehicle slots come in. The idea is that in career mode, you have a number of vehicle slots that you can use to have more than one plane. So if you break one of them, you can have other vehicles in other slots. So let's buy a new one, I guess, because that one is broken. So I have so many versions of this one plane. One of them should be good. It's probably the stock one. Let's get this guy. So there we go, little biplane. So hit go here. I don't know if you can hear that sound. The vehicle is now part of my collection. So that's actually a question that I have that's kind of open related. I was hoping to sort it out during test pilots testing. We have the option of making these wait periods happen in real time or in game time. And real time is effectively using the actual time of day. And then that would mean that if you have and that's sort of what you would see in most of these like sort of mobile games that have those long waiting periods. Not necessarily a huge fan of it, but it would give you the option to oh, that's pulling on an invisible thing. That's kind of creepy. It would give you the option to just continue waiting while you're offline or not playing. The other option is to have like a proper like passage of time system, and this is something that I would actually want to do, to have like the time of day actually passing in the game, and have that actually drive the game clock, or rather have the game clock drive that, but have the option to call it a day effectively, and doing that would like return you to the workshop and basically close down for the day, and a day passes in the game. I'm still kind of working that out because there's still kind of a missing gameplay elements, you could say, like that would make that actually meaningful. So it's all about like because this is because the idea is that this is going to evolve over early access, and we don't actually have all of the features that we want to have yet. There is a bit that needs to get done, like at first, so that we have like a proper solid like gameplay loop already, even if we don't have all of the elements. So this has been kind of like the main challenge, is that like we have tons of ideas, but there's no time to implement all of it. And there's some gameplay ideas that only work once you have everything set up. And so we've been trying to come up with solutions here that while we don't have everything set up, like is there anything else that we can do in the meantime, you know, to have like an interim gameplay solution that works with less elements. I guess that's a long-winded way of saying that it's an early access game and it's gonna change, but yeah, for now I've been using this time mechanic uh, as a nice way to have like a sort of meaningful penalty when you lose the plane and stuff like that. Right now I have developer tools enabled, so I can just do this and freely recover, but in career mode you don't get to do that. Um, like ultimately what I would like to do, and this is by no means me promising anything, what I would like to do is to have like a proper system where you buy the parts you need in advance and you possibly have to wait for them to arrive because you order them. And then that would create all sorts of new interesting like situations where you have to plan out what you want to do. And effectively, career mode is going to be, I think, ultimately something where you end up having like an RC club that you then develop. And and you can like using the rewards you get by doing missions and stuff like that, you'd be able to get upgrades for your RC club, like having this runway and having a runway that can refuel and repair your model, having the build tent added to the location and stuff like that. And so that would be like effectively a career in model aviation, because I reckon that's the only way you can actually you could possibly make money with this hobby. But yeah, another really major thing that we have added is characters. So these guys are your RC, I guess, club mates. And if I put the plane away, they will maybe look at me because they're much too interested in the planes. There we go. They're now looking at me. I have their attention. So these guys, they you interact with them to get missions and things to do. So if you talk to them, they will give you missions that you then select. These are just the test missions for the test scene. In game, the missions actually have content and all. And each of them has like a different theme of missions that they will ask you to do. Like Chuck here is all about racing missions. Ari is a certified flight instructor, and Sid is the guy you go to talk about discoveries and things that you can find around the map. So there might be secret areas or things that you can discover by flying around. And whenever you do, you can go to Sid and he will give you a reward. Yeah. So on how KSP1 has evolved in the last few years, um, to be honest, I haven't actually been following all that closely. I've been mostly very, very busy working here. So, and I've had very little contact with any of them as well, beyond the other guys who left back in 2016 as well. So they know about as much as I do, I guess. Um, but yeah, I don't actually have much of an opinion because I have I really have not a lot of, I don't really have much more information than the community does. So yeah, so this is just kind of like to give you a rundown of how career mode is shaping up. We have, you can actually level up as yourself. And when you level up, you unlock lots of new things. So including even editor tools. So you unlock parts, you can unlock missions and editor tools and additional vehicle slots for your planes, and also maps. You unlock maps as you go along as well. So so yeah. So this has been what I've been working on for the last several months. It's been quite a massive amount of work to do to add all of these new features. But yeah, and hey, we have part tooltips now that work outside of the vehicle editor. Ah, this is something that KSP could not do. I don't know if it can do it now, but yeah. So there we go. So on the subject of the catenary itself, I mean, it works. It's doing what I wanted it to do. Like it hooks up to some other point, and I'm using it to tether, well, that invisible balloon up there and this much more visible one here. And that's one use for it, and it's well, perhaps not the most amazing use, but the principle kind of is the same. Um, it's a rope, and we can use a rope like this in many situations, including, of course, towing aircraft around. So say you have something like a glider. If I give myself a glider here, let's just go and buy a glider. Like this guy. So this guy has no means of taking off on its own. The only thing you can do is hand launch it. But then that doesn't get you very far. Oh, one of the planes that was recovering is available again. So with the tow, you could actually conceivably have another plane, conceivably another player's plane, tow you up, and then you could disconnect and glide away. Yeah. So there you have it. This is well, I guess as far as the topic of the stream, which was making the procedural catenary lines, we definitely, I think, could say we've succeeded. Uh, invisible balloons notwithstanding, but for the very visible ones, we definitely have something that we can use. If I drag this guy up, you can see that, yeah, the line there is very much connected to the balloon. Docking missions, eh? Yeah, if you can think of a way to make that happen, I mean, this is I mean, there's a lot that you could do, and in fact, there is a lot that you could do because Balsa is entirely fitted with a complete scenario editor here. So this is the scenario editor, and it lets you create missions by using modules like this. And so this is the mission that I have attached to that red balloon. It basically starts you off with a waypoint route. Once you fly the waypoint route, it ends the mission and gives you career progress. But there's tons of other module and more modules to be added. So the idea is that this is how all of the game's missions are made. You can set up like objectives, rules, spawn NPCs, set up like combat situations, stuff like that. And you can also add props Like if I wanted to add like another build tent here, I just need to place it. And there we go. Like build tent. Or if I wanted to place something more like if I wanted to have like a special runway that you need to land at for a mission, I can just like draw out the runway. Where did it go? Isn't it fun how whenever you're trying to show stuff, things break on you? I broke something. It's got to do with a missing material or something or other. I just do this. I guess I can make it stop happening. No, it's broken. I might have to stop the game. Yeah, I know. That's how it usually goes. It's probably something to do with that one prefab. But yeah, defending off an attack is definitely a mission that you can do, and actually one that I even set up already, which well might need to be set up again because I'm in the process of revising all of the missions. But yeah, defending from attacks or doing like an airstrike, doing like precision landing or landing on like precarious places, doing stunts, flying through things, like all of that is very much possible. And racing as well. The AI is entirely capable of racing with you. So, and in fact, I actually have a racing mission here that I could actually show if it doesn't break. But yeah. Let's see here. Oh, here's to that. I also want to see it get big and have a big following. Hopefully, everything going right, things will turn out okay. So yeah, so that mission is with Chuck. So it's this test mission here, and just select the plane and let's see. The plane is spawned, and no, wait, this is the wrong mission. It spawned the wrong mission. It's not the racing mission. This one. I might have moved it. So this is a test that I set up for NPC combat. So you can see the mission is just spawning in like lots of NPCs on blue and red teams, and there's some anti-aircraft artillery as well here and there, and they're already in combat mode. They're going at each other. And I'm not sure if I am on a team or not. I think I'm not. Let's see if I can actually choose myself a team. I can't either. So this mission is really just for them. They will fire at each other. See, that guy shot the other. Yeah. Look at that. He actually managed to take that guy down. Ooh, bullets are cracking. So yeah, so this is just one example mission that I set up here for testing. It's not actually a mission as in there's no there's no end goal, there's no objective or anything like that. Like it just sets up the initial conditions so the NPCs can have at each other and yeah, and get into a dogfight. This is mainly just for testing the dogfighting AI, which very much does hopefully work. It does spawn some planes that don't actually have any weapons on them, which makes them less effective for combat. But oh well, that's on me. So there we go. So that guy definitely has weapons and it's chasing. Look at that. Oh, it got a hit on his own friend. Like they're not excellent at it, but they will, oh, that guy actually got a kill. All right, cheers. So there we go. Modular War Thunder. That's nice. I will take that as a compliment. You know, I've played a lot of War Thunder. If you put it in simulator difficulty, it's actually a pretty respectable simulator. It's not bad, and it actually does, it performs really well in VR. Actually, it's one of the best VR experiences for flight simming. Oof. Like I just took half of my stabilizer. Because they're chasing that other guy that can outturn them, I think. Yeah, so the AI might need some retuning because some of the flight dynamics have changed since the last time I did it. But yeah, at least they're not as bad as they used to be at trying to not crash. But the obstacle avoidance at least has improved. So yeah, this guy doesn't even have weapons. He's just trolling the blues. And that's me again. So I'm gonna stop this mission. So you can see also that the missions, you can start and stop them um, without stopping the game or without having to reload the scene or anything like that. And this is really interesting because you can do this in multiplayer as well. So the host of a multiplayer session or a player with admin permission can actually open the scenario editor uh, in a multiplayer session, set up a mission and hit start and play the mission in the multiplayer server, all without actually stopping the multiplayer session. So you can have like one multiplayer session going that just plays mission after mission, like continuously. That's the goal, at least, for multiplayer. So yeah, well, at least in terms of our procedural catenary, I would say we have done well, a fairly decent job. I think we have a procedural catenary rope that acts very ropey, even if it connects to an invisible thing up there. So yeah, I think that that's about the point where we can start to wrap it up because we've been we've been at it for 2.5 hours actually, but we've managed to put together a nice, convincing looking catenary string, like procedurally, um, that we can use to hook things to one another. And I'm pretty happy to see that. That's actually quite nice. So I think that we're just about ready to sign off then. So I want to thank everybody who joined in. Thanks for watching. Thanks for sticking with me this far. And this was actually pretty great. So we'll definitely do this more often. And I'm actually really excited to just be able to work like this and show it off, show what I'm working on off to everybody at a more regular basis like this. Like this is really cool. So yeah. So thank you all very much for joining, and I will see you on the next one. Cheers.